Welcome to today's math lesson. If you make your way to Schoology and you go to your math course, you will find all of our folders. Remember, for math, our folders are listed weekly so that you can find that specific day's work. So you will go to September 20th through the 24th. That's the current week that we are on. And today's lesson is the 22nd. When you look at this, I will have changed it to the 22nd through the 23rd because the presentation I'm about to go over with you will last for both days. So the first thing we're going to go over is Unit 1, Lesson 6, Session 1 through 3. So when you click on the assignment, it will prompt you to open assignment with Kami. Remember that when you finish these assignments, if you're wanting to turn them in online and not work them in your textbook, then you need to make sure that you have clicked the Turn In option. So we've been talking about expressions, and then today we're going to move on to the last lesson in Unit 1. And this lesson involves greatest common factor and least common multiple. And then we will also be talking about how to use distributive property to express the sum of two whole numbers. So we want to find the greatest common factor and the least common multiple. And then we also want to be able to use distributive property to express the sum of two whole numbers. So first, what I would like for you to do, if you have your math spiral with you, this really needs to go in your math spiral. But what I want you to do is we're going to take some notes in just a few minutes after we do our start problems. And we're going to talk about greatest common factor, least common multiple, and how to use distributive property to express a sum. So do have your math spiral and prepared to take a few notes after our start problems. So we have two start problems here. Number 3 says Miguel is covering his bedroom floor with carpet. He has already covered 3/4 of the floor using 7.5 square feet of carpet. What is the total area of the floor in Miguel's bedroom? So if we have a carpet and we've done 3/4 of that, and that was 7.5 square feet, right? We can figure out how much the total area is if we divide. So we have 7.5, and that was 3/4 of the carpet. So if I have 7.5, I want to change that to an improper fraction. So that would be 15 halves. And then I'm going to divide that by 3/4. When you are dividing fractions, if you remember from 5th grade, we keep the first number or fraction, change division to multiplication, and then flip the fraction. Instead of 3/4, we would have 4/3. So we keep, change, and flip. Then you multiply. So 15 times 4 would be 60, and then 2 times 3 would be 6. Remember that fractions are division, so 60 divided by 6 is going to be 10. So the entire area there is 10 square feet. So that is how we would answer number 3. There are other ways to get to that answer, and that's fine if you found a different way to get to that answer. And then number 4, there's multiple ways to find this answer as well. The most common one that I've seen in class is for the students to go ahead and look at the entire box, okay? And to find the area of that entire rectangle, we would do length times width. So our length times width right here is 12 yards times 8 yards. And when we do that, 12 times 8 would be 96. And then we have yards times yards, so that becomes yards squared. And I'm sorry, I just did that wrong. Guys, ignore me. Our entire box is going to be a 12 by 12. Because our distance from here to here is 12, and then from here to here is 12. So 12 times 12, and then you would get that answer. And then you find the area of the porch and you subtract that from your answer there. That's one way that I saw it worked in class. That was a pretty common way. That was about half the class. And then the other half of the class worked it the way that we have talked about these shapes. So they went ahead and ignored the porch, and they said that this is the yard, and we need to find the area of the yard. And there is not an area formula for an L-shaped figure. Instead, we have to break it up into shapes that we do have area formulas for. So we call that decomposing. So we decompose the shape, and you can divide it there like I did. There is one other way that some students divided it, and that was going this way on the shape. It doesn't really matter which way, just as long as you have divided it. So you divide the shape into two shapes, in this case, a rectangle and a square. And to find the area of a rectangle, we do length times width. For this top rectangle, that would be 12 times 4. And 12 times 4 is 48. Then we would look at this square shape that we have left here. And we know that this top part was cut off. So we don't need that entire 12 yards here. Instead, we only need from here to here. So if 4 yards was cut off when we did this other shape, then that leaves us with 8 yards. So we have 8 times 8 for this one. 8 times 8 is 64. And then we would add those areas together because those shapes are really connected. We just had to break it apart in order to use our area formulas. So when you add that, you would get 112 yards squared, and it is yards squared because we are talking about area here where we're multiplying yards times yards. It doesn't matter which way you did it, if you did it the way I just explained on the video, or if you did it the first way that we talked about, you should still get the same answer, 112 yards squared. So that is how we do those two problems. And I told you guys that you would be taking some notes. So I want us to pull out your spiral if you have it. If you don't have your spiral, you can always go back to this slide here and take some notes there. So we want to talk about your greatest common factor. So we need to know what a factor is. So factors are those things that you multiply together to get a product. So something times something equals 12. Well, the two numbers that you multiply together to get to 12, those are factors. Well, 12 has more than two factors. There's more than two numbers that you can multiply together to get to 12. So let's look at the factors of 12. If we have the number 12, we can multiply 1 times 12. We could do 2 times 6. And then we could do 3 times 4. And when we do that, those are our factors of 12. But when we're finding our greatest common factor, if two things have something in common, they share. So we need to find the greatest, the largest factor that would be shared between two numbers. So let's use 4 as our other example. So the first set of factors would be 1 and 4. 1 times 4 is 4. Then 2 times 2. You can write 2 just once, or you could put it on both sides. It doesn't change the fact that 2 is just there. And then that's as far as we go with 4. So now we find the greatest common one, the one that's the largest that they both have. And we see that that is 4 and 4. So the GCF, or greatest common factor, between 12 and 4 is 4. Now let's take a look at our least common multiple, or sometimes referred to as your LCM. Well, just like we need to know what factors are, we need to know what multiples are. So multiples, I like to think of it as skip counting. So it's like counting by that number. So if you were doing your multiples of 2 would be 2, 4, 6, 8, 10. So we would just keep going from there. So multiples are kind of, I like to define it as your skip counting. So it's all of those things that you get when you start with, say, 2, and then you do 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So those would be your multiples of 2. You could also think of it as adding by that number. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. Lots of different ways you can think of it. So not a mathematical definition, but skip counting works for me. So let's use those same numbers. Let's use 12 and let's use 4. And we're going to list the first 3 multiples of 12. So if I'm counting by 12s, I would start with 12. And then 2 12s would be 24. And then 3 12s would be 36. All right, so that's my first 3 for 12. And let's do our first 3 multiples of 4. So I would start with 4. 2 4s would be 8. 3 4s would be 12. And then I want to find the least common one. So the smallest one that they have that's the same would be 12. So that is our least common multiple of 12 and 4. So it is important that we understand the difference between greatest common factor and least common multiple. So again, make sure that these notes are in your spiral, please. And then we want to talk about distributive property. So before, when you used distributive property, you talked about it when you did multiplication. When you your very first strategy to multiply was probably expanded form, because you had already had practice in 3rd, 4th grade with writing numbers in expanded form. For example, I could write 360 in expanded form. I could write 300 plus 60, and then I wouldn't have to write the plus 0, right? Well, distributive property says that I can take that expanded form and multiply it times 4 times my other factor. So then I would say 4 times 300 is 1200, plus 60 times 4 is 240. And then I add that together to get 1440. So that is just a strategy for multiplication. That's probably the most common use I have had in the past with teaching other grade levels as far as distributive property. We want to be able to take a sum of 2 numbers and we want to be able to write it as distributive property. The example given in the standard is 36 plus 8. So in that example, you will see that they have pulled out a 4. They both share a factor of 4. So 36 has 4 as a factor and 8 has 4 as a factor. So 4 times 9 would give you 36, and 4 times 2 would give you 8. So that's where they got that distributive property for that example. So that's what we want to be able to do. We want to be able to find greatest common factors, least common multiples, and then to also be able to find or express this sum as distributive property. So again, make sure that those notes are in your spiral, please. All right, let's move on to our try it problem. If you're following along in your textbook instead of working this online, that's perfectly all right. This would be on page 109. So with this try it problem, it says a floor plan for a new house shows a linen closet with an area of 12 feet and a clothes closet with an area of 18 feet. The two closets will share a wall. What are all the possible whole number lengths of the shared wall? So this person is drawing up the floor plan. So if you have ever seen a floor plan for a home, then they have all these little boxes that represent closets and rooms and all kinds of things. And typically our closets are in the shape of a rectangle or square. So you have a linen closet that is 12 feet squared in area and a clothes closet with 18 feet squared. Well, let's think about this. How do we find the area of a rectangle? Well, we would do length times width for each one. So they could possibly share one of these that you are multiplying together. When we multiply two numbers together to get to a product, then we are finding factors. So if I find my factors of 12 and I find my factors of 18, I should be able to see some of them that are the same. So my factors of 12, we talked about those just a little bit ago. We have 1 and 12, 2 and 6, 3 and 4. All right. And then with 18, we have 1 and 18, 2 and 9, 3 and 6. So we want to find all of the ones that they have the same because the problem says what are all of the possible whole number lengths. So we have 1, that's the same. We have 2, we have 3, and we have 6. So all of those could be the possible width that we're looking at. So when I'm doing this, my answer would be I could have a 1 foot shared width. I could have 2 feet, 3 feet, or even 6 feet. So those are all of the possible widths that it could share. So make sure that you have that on your page or on your screen. As we're going along through the video, just like with any other video that I record for you guys, pause, rewind, do whatever you need to do to follow along with the video, and then also try to attempt things on your own as well. Okay, that brings us to the apply it questions that are on page 116, I believe, in your textbook. Let me double check that page number before I go with that being it. So, yes, that is on page 116. So what you're going to do is, it's not as complicated as the STAR problem. You are going to find the greatest common factor. So for the greatest common factor, you have 56 is one of the numbers you need to find factors for. And then you have 96. So what I would do is I would start with the number 1 and then just move on through your numbers 1 through 9 to see just kind of where you get. So 1 times 56 would be 56. 56 is an even number, so it should be divisible by 2 as well. So 2 times something is going to give us 56. If you need to come over to the side to do this, you can. So 56 divided by 2. 5 divided by 2 is 2. 2 times 2 is 4. You subtract, you get 1. Bring down your 6. 16 divided by 2 is 8. 8 times 2 is 16. We subtract, and we get 0. So 2 times 28 will give you 56. Then we need to see if 3 is a factor. So we would come over to the side again and do 56 divided by 3. 5 divided by 3 is 1. So you subtract 3. You get 2. Bring down your 6. 26 divided by 3 is not going to work out evenly. So we don't have any factors there with 3. Then we would need to check out 4. 4 does work as a factor. Again, you can come over to the side and work that out. If you have a scratch piece of paper, if you're having to come over to the side and do a lot of this, then a scratch piece of paper would be great to work with here. So this would be 14. 56 is not going to have 5 as a factor. It will not have 6 as a factor. It does have 7. 7 times 8 is 56. And then 9 is not a factor of 56. 10 would not. 11 would not. So we're going to move on over to our factors of 96. So when we're looking at our factors of 96, we want to start with 1, just like we did before. And 1 times 96 will give us 96. And then 2 is also going to be a factor here because 96 is an even number. So if you need to go over to the side to see what that one would be, find out what we multiply 2 by to get to 96. And if you need to pause the video, you can. All right, so when we're looking at this again, 1 times 96, and then 2 times 48, 3 times 32, 4 times 16, 6 times 12, that should be 2 times 48. So we have 1 times 96, 2 times 48, 3 times 32, 4 times 16, and then we have 6 times 12. And I see another mistake here that I've made. So right here where it says 4 times 16, that should be 4 times 28. No, times 24. Sorry, 4 times 24. And then it should be 6 times 16. And then you would have 8 times 12. All right. So if we're looking at this and trying to find the largest number that's the same, well, we don't have 56 over here in the 96. We don't have 28 anywhere over here. We don't have 14, but we do have 8. So our greatest common factor of 56 and 96 is 8. So, if you're struggling, like your teacher is, with your factors and listing them, make sure that you're showing your work over to the side. All right. So, let's clear all this out. All right. Hitting the clear button, but it's not clearing. So, I am going to need some space to work. That's not working either. All right, so that's just kind of stuck on my screen there. So if I look at number 7, it says, Reth says the greatest common factor of 36 and 60 is 6. Is Reth correct? Explain. So if we have the number 36 and we're doing factors are what we multiply together to get to that number, right? We have 1 and 36. We have 2. And if we're finding if we're finding 2 times what is going to give you 36, then we could come over to the side and divide, and that would be 18. 3 is a factor of 36 as well. 3 times 12 would give you 36. 4 is the next one that we would take a look at. And we know that 4 times 9 is 36, and I have run out of room here. But my next one would be 6, and 6 times 6 is 36. So 6 is also a factor of 36. And then we look at 60. So with 60, if we started with 1, we have 1 times 60. We have 2 times 30. We have 3 times 20. We have 4 times 15. We could do 5 times 12. I'm going to take this over here. So 5 times 12. And then we could do 6 times 10 as well. So we want the greatest common factor. So let's look at the common factors here. We see 1, but that's not going to be the greatest, obviously. Reth says that it's 6. So this one has 6. This one has 6 as well. But do they share a larger one? So I would look in my larger sides over here. 36, 18, 12. Well, I see 12 here, and I see 12 here. So he or she was not correct. 6 is not the greatest common factor. 12 would be the greatest common factor. So that is one way to work that problem. So when you're finding greatest common factor, you can actually list out your factor trees. All right, let's take a look at our next problem. If you're working from home, I would like for you to try this one on your own and then share what you did with someone at home if you can, and then come back to the video and check it out. Okay, so Lewis buys 16 bellflowers and 20 roses. He wants to plant an equal number of bellflowers and an equal number of roses in each of his flower boxes. What is the greatest number of flower boxes Lewis can plant using all the bellflowers and roses? Show your work. So we can find this by looking at our factors here. So we can see that if we were to list our factors, I'm going to do a different color here. If we list our factors of 16, then we're talking about 1 times 16, 2 times 8, and 4 times 4. If we're looking at our factors of 20, then we have 1 times 20, 2 times 10, 3 is not a factor, 4 times 5. And then we could, we could not do 6. 6 is not a factor of 20. 7 is not going to be a factor. 8 is not a factor. 9 is not a factor. And then that brings us back to 10, which we already have as a factor. So those are our factors of 20. And if we look at the one that is the greatest that they have in common, then we see that they both share 4. So the most that he could do is 4 boxes. And again, I apologize for all of this over here. It's just not really going away. So let's continue on to our next problem. So it says Ria is buying plates and cups for a party. She wants the same number of each. Plates are sold in packs of 8. Cups are sold in packs of 12. What is the least number of plates and cups that Ria can buy? And let me make sure of page numbers in case you're working on in your textbook. All right, so with this problem, we are looking at page 122 is where this would be in your textbook. So this time, we're not looking for factors, we would be looking for multiples. And it wants to know the least number of plates and cups that she would have to buy if she wanted the same number of each. So if we're listing our multiples of 12, then we also want to list our multiples of 8. So if we're counting, let's say by 12, we would go 12, 24, 36. All right, so let's go over here to 8. We would start with 8, and then 16, and then 24. So now we have reached one that they have that's the same. So that is the least number of each that she could buy to have the same number. So if she bought 2 packs of cups and 3 packs of plates, then that would be 24 cups and 24 plates. Now let's take a look at number 7 here. It says in problem 6, suppose that Ria wants at least 40 plates and 40 cups. Could Ria buy exactly 40 plates and 40 cups? So if we're thinking back to that previous problem, number 6, then we were looking at cups are sold in 12 packs and plates are sold in 8. And if we're looking at this and we look at our multiples of 12, well, is 40 a multiple of 12? Is 40 a multiple of 8? Yes, 40 is a multiple of 8. So she could get that with the packs of cups, but she could not get that with the plates because 40 is not a multiple of 12. So that would be my explanation there. She could get 40 cups with exact packs, using exact numbers, because it is a multiple of 8, but you cannot do 12 because 12 is not a multiple of 40 is not a multiple of 12. All right, number 8. When Carlos goes to his favorite restaurant for lunch, he gets a sandwich and a smoothie. The restaurant has 2 reward programs. Buy 10 sandwiches, get 1 sandwich free. Buy 4 smoothies, get 1 smoothie free. How many times does Carlos need to buy a sandwich and a smoothie to get both of them for free on the same visit? Show your work. So with this problem, let's think about what's actually going on here. So you buy 10 sandwiches, you get 1 free. Buy 10 more, you get 1 free. So we're going by tens. So 10, 20, 30, 40. Well, those would be multiples. And the same thing with your smoothies. You buy 4, get 1 free. 4 more, you get 1 free. So 4, 8, 12. So we continue on that way. So if we figure out our least common multiple, then we would know how many times he needs to buy a sandwich and a smoothie. So we have 10, 20. Well, I can stop right there because I know that 20 is a multiple of 4 because we would have 4, 8, 12, 16, and then 20. So he would need to buy a sandwich and smoothie 20 times to get both of them free on the same visit. All right, that brings us to 2 more try it problems. These are problems I want you to try on your own. I'm not going to go over them on a video. If you have questions about them, and you won't be back at school anytime soon, then just message me and I'll Zoom with you and go over them. Otherwise, just complete them on your own and put your answers. I'll look at it if you submit it and give you some feedback. And then we'll just kind of go from there. But these are both try it problems that involve real world situations where you might have to find greatest common multiple or greatest common factor or least common multiple. So those 2 try it problems are for you to try out on your own. And if you have any questions, let me know. But hopefully with what we've done together so far, you won't have a very difficult time with those 2 problems.